So lesson 8.6, we're going to look at square roots and cube roots. Shouldn't be a brand new concept, but maybe dive a little deeper than we have in the past in middle school, Math 7, Math 8. So your big idea, if a first number is the square or the cube of a second number, so square meaning you squared it to the second power, then the second number is a square root of the first. So basically, when you square and square root, those are opposites of each other, just like multiplying and dividing, kind of reverses each other and puts you back to where you started. When you square something, to go back to the original, you're going to square root it. All right, and we'll dive a little deeper into that. So the definition of a square root says, if you have a equaling s squared, s is a square root of a. Now, at first, that just seems like, some math terms, but let's dive a little deeper. So if some number equals another number squared, okay, s squared equals a, some number squared equals a, then this number s is considered a square root of a. So here's what we can look at. Let's take something simple. Let's take 9 equals 3 squared, right? 3 times 3 is 9. So 3 is a square root of 9. And the way that looks is you square root a number. Looks like a little check sign over it. So the square root of 9 is 3. Or actually, there's another one, negative 3. And we'll talk more about that. Because if I take negative 3 squared, negative 3 times negative 3, I can get 9. If I take 3 squared, 3 times 3, I can get 9. So both of them are square roots of 9. So the square of a square root property is for non-negative numbers. What it says is, if you have the square root of a number and you multiply it times the square root of a number, anytime we do this, we actually end up multiplying the inside numbers and then putting the answer underneath that. So if I did x times x, I'm actually going to get x squared, and the square root of any number squared is just that number. So basically, we're going to end up skipping this middle step. If you have the square root of something times the square root of something, you're going to get that number. So let's do an example real quick. If we have, let's see, square root of 16 times the square root of 16. So first of all, think about the numbers. The number that when you square it gives you 16. That's going to be 4. 4 times 4, 4 squared is 16. Times the other square root of 16, which is a 4 again. My answer is going to be 16. 4 times 4. So this property says that if I take the square root of 16 times the square root of 16, I actually just get 16. So we can kind of skip this step right here and say, well, if I'm multiplying a square root times itself, I just end up with this number that was on the inside. All right, the definition of a cubed root, very similar. So if v equals s to the third, so now we're cubing something, same idea though, then s is a cubed root of v. So for instance, 27 equals 3 to the third. 3 times 3 times 3. So that means the cubed root of 27 is 3. So this looks like a square root sign, but it's got the little 3 here. And so it's called the cubed root. And it's what number times itself 3 times produces 27. And that'd be 3, because 3 times 3 times 3 gives you 27. Now, the cube of a cube root property, very similarly to this one, says if you have the cubed root of x times the cubed root of x times the cube root of x, so it's going to have to be 3 because cube is all about multiplying something 3 times. You're going to end up with, inside of all this, x times x times x is x to the third. And the cube root of x to the third is just x. So this goes right back to what we did here in the orange. So let's go ahead and put a number in here that's got a nice cube root, so 27. So if I multiply the cube root of 27 3 times, cube root of 27 is 3, so times 3 times 3. 3 times 3 is 9, times 3 is 27. So if I multiply any cube root times itself 3 times, you get that number that's on the inside. So basically that's going to fall off. Now where we're going to use this a lot, and it's kind of geometry, but you're going to see a lot of it in algebra too, is with the Pythagorean theorem. And what that is it's used to find side lengths on right triangles. And hopefully this isn't brand new. I'm pretty sure you spent a lot of time in Math 8 on the Pythagorean theorem. So a right triangle means there's a right angle inside a triangle. When that happens, there are two sides that come out from that 90-degree angle, and we're going to call those the legs. And we label those A and B. And it doesn't matter which one you call which. Okay, this can be A, this can be B. And the third side that is actually across from that 90-degree, we're going to call that C. And that's called your hypotenuse. So that's important. We're going to label that. So C is your hypotenuse. B is a leg. And A is a leg. So it's important to understand that because our equation, the Pythagorean theorem, is A squared plus B squared equals C squared. And so this holds true for every single right triangle in the world. If you square either one of the legs and you add it to the square of the other leg, that's what A squared plus B squared means. So you square both of these numbers and add them together. That answer that you get is this number squared. So if you took this number and squared it, you'd get that answer of adding these two squares. So this is going to be very helpful, and we're going to hit that down here on example number 2. But this is one that you're going to want to remember forever. Pythagorean theorem, A squared plus B squared equals C squared. All right, let's jump into the work. Example number 1, we're going to calculate the square root of each one of these. So the square root of 64 is the number that when you square it, you get 64. So 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. What number times itself gets you 64? That would be 8. So it's 8 or negative 8. If I'm going to calculate the square root, this is how you take the square root. That's the symbol. Because negative 8 times negative 8 also gets you a positive 64. So it's actually either one of these answers. And mathematically, the way that you're going to write that looks like this. You can do it either way. You can say 8 or negative 8, but this is the more efficient way to write it. This is plus or minus 8. So it's telling you it can be positive 8 or negative 8. So what if it's a number that's not so nice that we don't know off the top of our head? We're going to grab the calculator. We need to know how to take a square root. And so it's fitting. Here's your x squared button. Right above it is your square root because they're opposites of each other. They basically undo each other. So if you want to take a square root, you got to get to this blue one. So you're going to hit second and then the x squared button. And then you're going to put the number in that you want. So 25.25. And we're going to round this. And remember that square root is always going to be the positive and the negative, just like 8 and negative 8. So we're going to say plus or minus 5.0. Let's just round it, 5.02. So we'll say that this is approximately that. Now if you wanted to see this one, just to see how it works, square root of 64 is 8. So notice your calculator is not going to give you both. You have to know that it can be the positive and the negative. All right, so 17.3. Let's try that one in the calculator. Second square root, 17.3. Most square roots are not very nice numbers, so we're going to round it. So we're going to write approximately positive or negative 4.16. Okay, so that's how you find a square root. Pretty simple. let's go ahead and now use this. So here's your Pythagorean theorem. As soon as you see a right triangle, you should know that you can use this to find a side length. So we've got a squared plus b squared equals c squared. A and b have to be these legs. It has to be these two numbers that are coming out from your right angle. So it doesn't matter which one you call which. I can plug m in for a, or I can plug m in for b. I can plug 12 in for a or 12 in for b. That doesn't matter. But what does matter is 14 has to equal c in this equation, because that's the hypotenuse. It's across from the right angle, and it's always going to be the biggest side. So when we go to plug in here, it doesn't matter what you put in for these two. So I'm going to put m in for a, and I'm going to put 12 in for b. But if you reverse those, it's perfectly fine. The legs can go in for either one. But then c has to be 14. All right, and now we're going to go ahead and just solve this equation. So we can't do anything with the m squared. You're going to leave that alone. 12 squared is 12 times 12. You see, it's 144. And then 14 squared is 196. And you're going to solve this even though we have this m squared, just like we normally do. If it's just an m, you want to get it by itself. So I'm going to minus 144 from both sides. So I'm left with m squared equals, this is 52. Now, we want to know what m is. We want to know what the actual length is. So this number squared is 52. So I want to go the opposite way. I want to know just what m is. So whatever it is times itself gave me 52. So if I find the square root of 52, it will give me m. So to eliminate a square, you take the square root. It's reversing. It's like when you see multiplication and we divide to get rid of it. If you see square, you're going to take a square root to get rid of it. And so when you square root a square, you're going to get just m by itself. And then we're going to take the square root of 52. And we'll round it. So it's approximately 7.2. So I'm going to put the approximate symbol here because we did round it. 7.2. All right, so this is where using a square root is going to come in. If you've got m squared equals something and you want to know what's just m, you're going to take the square root to go backwards. So let's flip it over and let's take a look at a couple other ones where we could see this. So we've got the area of a square is 169. What's the length of each side? So square, meaning all the sides are the same. So if this is x, so is this, and so is this, and so is this. Because it's a square, it's not just a rectangle, it's a square. All the sides are the same. So we know area is the base times the height. Well, in this case, area is going to equal, the base and the height are the same. So x times x. So that means the area is going to equal x squared times itself. Now, they already told you that the area of this is 169. So we can plug that in for a. Area is 169, and what we want to do is we want to figure out what's x. So what number squared gives me 169? So you can keep timesing numbers by itself, 9 times 9, 10 times 10, 11 times 11, until you figure this out. But it may be a decimal. In this case, it's not, but the quick and easy way to do this is to take the square root. If something squared is 169, we can take the square root of 169 and find out what x is. So we want to know, what does x equal? We're going to take the square root of 169. And it's nice, easy 13, because 13 times 13 is 169. So if the area of a square is 169, we know that the side is 13. Now let's look at a cubed root. So if we go to last example, it says the volume of a cube is 514. So a cube, three-dimensional object. Not a great drawing here, but you've got your three-dimensional box basically. Now if it's a cube, that means all the sides are the same. So the base, the height, the length, they're all the same. Volume of these types of shapes is length times width times height. So the bottom times the height times how far back it goes. Well, in this case, that number is going to be the same because it's a cube. The height is the same as the base, and it's the same as that because it's a perfect square cube. So it's x times times x. Well, that's x to the third power. So volume equals x to the third power in this case. They already told you what the volume is. It's 512. So if I multiply these three numbers together, I have to get 512. So x to the third power is 512. And so I want to figure out what number times itself 3 times is 512. Now, cubed root doesn't have a perfect button sitting here. So where you go is you go to math. You click on the math button. And you go down, you can see right here, this is a cubed root. It's the little check mark cubed root, and it's got the 3 there. The one underneath of it with the x means you could put a 4 or a 5 or 6 or a different kind of root in. Now, we just want cubed root, so you can just press number 4. You'll see it'll pop up with the little 3, and that's what we want. And so we're trying to take the cubed root of this. What number times itself 3 times? X times x times x gives us 512. So we're going to go ahead and punch in 512. And you'll see that it's 8. So x equals 8. And here's what that actually means. 8 times 8 times 8 is 512. So if all of these sides were 8, length times width times height, 8 times 8 times 8, we would get 512.